2 hours and 10 minutes. All right. So I'll do like an hour of stats and then an hour of SQL. We'll do something like that. Since SQL was actually not curriculum, and I want to make sure I cover that. So in the momentum, I'm going to get set up, guys. We probably will not get to stats models. I know I was like, yes, I love carpet. It saves my technology. Thank you.
Wood floors are out.
Yeah.
Yeah. Guys, keep your carpet. It's the best. I have some stuff in stats models, but my fear is that if I just jump into it, it's going too advanced. So I want to start with just moving through stats functions and progressively creating more complicated stats functions. But we'll see how it goes. Because, show of hands, who here is taking like stats 1 in undergrad or college? Who's taking stats 2? Who's taking a stats 3 or higher? Yeah, so a lot of people don't even have stats background. So I want to like start at the fundamentals so it's not too complex. But I think you guys are going to love it regardless. We're going to do some graphings. We're going to do some stats. It's going to be a statistics party. Okay, what's happening? Okay, so what we're going to start with is let's create a new Jupyter notebook. And we're going to type this code. Ooh. So start a new notebook and type this code. And I'm going to explain to you what everything does. I do one thing here, lambda, because someone requested lambda functions. So I just want to explain to you how they work. So we're going to do part at a time. So first, this part should all be familiar. So start your new notebook. Well, it's kind of down there. We have matplotlib notebook or inline, but this is great. Import pandas, import numpy, import pyplot, matplotlib. Okay, so this should all be a review. It's not going anywhere, just trying to, okay. The second thing is we're going to do two things here. We are going to create a dates data set. So we're creating a variable called dates that equals PD, so we're initiating pandas package, dot the date range method, where you can choose a starting date in quotes and comma select how many periods, and then we create that many dates. And it goes up in iterator count of 1 day. So right here we're creating a variable that is a data frame that stores the dates January 1st, January 2nd, 3rd, 4th, and 5th, and 6th. So that's what this row here is going to do. There's a lot of different functions in Python that lets you generate data. So I'm not having us use a data set here, we're generating data. The second row, we're also going to generate data with a different function. The one up here is through pandas. The one down here is through pandas and numpy together. So I don't know if we've seen this yet, but we can combine packages together. So we're going to create a data frame. I like calling data frames df in general, or you can give it a specific name. So df equals pd, pandas function, dot the data frame method. So we can use the data frame method to create a data frame from nothing. And in there, we're going to apply numpy with the random rand_n subpackage method. Rand_n is random number generator. So for anyone who's ever wanted to run random numbers, like lottery, what student presents first in class, or so forth, rand_n does that for you. We're requesting it to be 6 and 4. What does that mean? It means that the number, we're going to have the 6 rows and 4 columns. So specifically here, this is rows by columns. So whether we want that data frame to be shaped by, I want 6 rows with 4 columns of data. I'm creating a matrix from scratch. Additionally, what's important to know about this random number generator is the values are typically from centering at 0 and having a standard deviation that goes out, right? So it could be positive or negative, and I'll show you that shortly. I'm trying not to get too much into the stats, more the Python, so you can definitely study more on like normal distributions. But what we have here is pandas data frame using the random number generator for 6 rows by 4 columns, index being dates. Index means your first column, so like whether your title is actually going to be in those rows. And then columns, how you want to title them. We don't have column titles, so we can use the list method to title them A, B, C, and D. We put them together, but it separates them. So I know this looks like a really complicated thing, and I can explain more in depth, but when you type DF as output, you should get something like this, and all your numbers will be different than mine, because we use the random generator. So we have the columns and the rows, A, B, C, D, dates, and some numbers. So this is all our first experience of generating data by ourselves. I wouldn't expect you to have this memorized or know it just yet, right? So, but you can see it's not really hard code, it's just getting familiar. The new things here are we can run packages within packages, so NumPy within pandas, and then we can run multiple conditions. So we choose the data, and then these two are just titling the data, titling the index, the rows, and the columns over there. That's not lambda. This is leading up to lambda. So there's a reason I'm doing this.
Did you execute this one?
Green sticky if everything is working for you so far. If when you type DF, you're getting an output that looks something like this, please put up a green sticky. If not, put up a red sticky so we can see what's going on with your syntax. By default, it centers 0 to 1, right? What's that? Do you know why it's?
Why it's offset?
Yeah. Huh.
No.
I know in general that it centers at 0, and we're looking at standard deviations above and below. Why is it under 2? It might be some. Oh no, we have a 3.14 in my case down here. So it could technically go 3 to the right, -3 to the left, or slightly above or below. It's like a normal distribution. I'll just throw that up on the board for those who haven't seen it before with a marker.
Right here.
Amazing.
Do you mind
Cool.
if I just scroll up a little bit?
Yeah, and let me zoom it out a little bit so we can see more actually.
Okay, thanks.
Oh no, let's hide lambda. That's fine. I'll explain lambda in a second. But, so right, for statistics, this is a normal curve. Who's seen that before? Great, hopefully everyone, or mostly everyone. Where we center at 0, and if we're 1 standard deviation to the right or the left, typically that's 68% of your data. And then 2 standard deviations is the 95%, and 3 standard deviation is the 99. So we have this rule called 68, 95, 99.7, which is known as the empirical rule. 1, 2, 3 standard deviation, or sigma. So for that reason, your numbers should also be somewhere generally from +3 and -3. Okay, so what is lambda? This is just the whole purpose. Lambda lets you create a function without defining a function. So before, when we created classes doing def and typing a class, you can create your own temporary one in the line without having to go through the whole hassle. So that's what lambda is. So in this case, we could do df dot apply. So we're going to apply to the data frame a function. Lambda, it just means I'm creating a function. The name of the function is x, or the variable x, colon, such that I want to find from the data the max minus the min. The x in Lambda is treated like a loop. So we're looking through each row or column, depending on how we classify it. We're applying x here to the function. And in general, when we work with stats, we don't look at rows as much, we look at columns. Each column is a feature, each column is an attribute, each column is a variable. They're all the same words in stats. So we're measuring the max and the min differences for each column, where it's treating each column as a variable. So theoretically, we can, not theoretically, quantitatively. So for A, it says 2.3. So if we look here, the max is like, I don't know, 0.43. And the min is negative 1.69. And the difference of that is 2.3. If you don't believe me, you could actually do something like df.a.min and then df.a.max. And we see those mins and maxes. I messed up. It's not 1.69, it's 1.87. I'm a huge, huge fan of dot notation. Dot notation is just shortcut notation. So typically, I hate brackets. There's nothing wrong with it. Brackets are just as effective, just as awesome as dots. Dots are just a shortcut. Some people who have coded before, you're very familiar with brackets. It may be like ingrained in your culture. Just use it, same thing. But if you're new to Python, highly encourage you to do everything with dots. It's effective, cleaner, easier to read. This is just validation for me, right? The difference of this minus this is positive 2.30. Positive minus a negative, positive. Okay, so that's all Lambda is. You can get like super advanced, do tons of calculations, math, and so forth. But it's an easy way to get statistics or things you want to know about columns. So you asked for a Lambda, right? So we can get more way advanced, but that's the scope we're going to cover here. Does that help a little bit? Cool, awesome. Sweet, so that's your introduction to Lambda. Questions, thoughts before I move away from Lambda and start going into more stats? All right, see, this is what Jacob mentioned earlier. You can do like Apple, oops, not that shortcut. Control M, switch to Markdown. That didn't do it, but just type Markdown. Now I'm going to write down statistics functions. And now I'm going to do stats. Just tiny little bits of Markdown. Okay. I need to give you guys a data set, so we're going to use another data set. How should I give you this data set? Let me upload to Drive and put on Etherpad. Where's my data set? I had it earlier. Oh, it's hiding over here. So for those of you who've done some stats before, you've probably heard of Ozone and MT cars. They're actually like really standard data sets built into Python. But I'm just going to give you these files so we can practice working with CSVs. So let me share the link. Okay, so if everyone goes to Etherpad, underneath Bokeh, putting a new link. This is our statistics data sets that we're going to work on. So open up Google Drive and please download both Ozone and MT cars. When you click on it, it should open up the folder. Your will look slightly different, but just download. Don't click on each file. Like actually, like you can click, right click, and download, but don't like double click because you're not going to see anything. It's going to look weird. So just like you'll see it, but it's not valuable. So you could like highlight them and then press download. That'd be great. Everyone take off your stickies, and then once you've downloaded your files and put them in your data folder, put your green sticky back up. What OS is its other interfaces that help with your operating system. So you can depend with the OS to open files. You can use it to view data as if you would do in shell. So that's all. It's just a module that can help you open files. We're not going to do too much of it, but basically there's an issue with Jupyter. Not really an issue, but Jupyter can run Python. It can't run Unix or shell. It can't run these commands. So there's two solutions to it. Solution number one is you can run from terminal and run Unix shell commands and then call Python scripts. Or you can do Jupyter Notebook with the OS package, which gives you the authorship to access Unix shell and command line scripts. So we're going to introduce this package so that will run nice for us. I'm going to put the link for it also on Etherpad, just in case you're curious about the OS operating system command line shell package for Jupyter / Python, just so you have it as a reference. Cool. All right, so now let's see why I'm going to do this. So let us create a data. Well, we did it before. We imported pandas, but we didn't import OS. So let's import OS. So now we have access to all these command line tools. Really cool. I'll also put this more up because I figure it's tough to see. Okay. And now we'll create a data frame called data. And we're going to do PD for pandas. We're going to read in the CSV that we just brought to our computer using the os.path.join method. What this does, this is an alternative from just going into pandas. If we were to do pandas, so let me show you without join, we would do this, right? Apostrophe, tilde, let me try to find where it is. Let me go all the way in. Well, OS lets you do, let me leave that, right, like as a reference. Let me put them side by side, actually. This will be great. So desktop, I put mine, let me actually put mine in the same folder as you guys, so it's not really an issue. Data, under data. Okay, so desktop, data, I'm actually under DC. I want you to know that Python is case sensitive. If I type DC, nothing's coming up. If I type capital DC, my folder is coming up. Okay, and I want the ozone, right, this guy. So this is how I would load it. Okay, it works, but with OS instead. So I'm going to comment it out, by the way, just as a reference for us. You can comment out, so the code's not actually read, it's there as a reference. So instead with OS, it's data is pd.read CSV, and then we're calling the OS package. So just like before we ran NumPy in pandas, now we're running OS in pandas, so two packages together. Calling on a path, and we're joining the path such that I can go down a level and go down another level, and then choose the folders I'm going in. So this would mean that, notice up here, my main level is users. So dot dot, depending on where I'm at, this would take us up a level. Depends where we're at. Huh. Because if I want to do this, let me see something. So what this does, in this case, let me not get too complex on it, but depending on what your Active Directory is, if you were doing a project that wasn't in your parent folder, like users, say you, actually this is true. We started our notebook, your notebook is probably in your data folder, right? So what this does, dot dot lets you go up a directory. And then the things that would follow, for example, this wouldn't be the case, but assets or data set will let you go in a directory each time. So this is a way to go up and then go back in. Let me make this more practical. So if I save, where is my Jupyter notebook? Oh, this is great. It's under David Jacobovich. Yeah, so I'm under my user folder right now. If I do dot dot, that takes me from here back up to users, right? So that's not really helpful, but if I was in a separate folder and I want to go back up and go into a folder, this is a way to switch folders. So let me just show, I go dot dot back to users, and then I can go into, I can go back into my folder, so I can go into David Jacobovich, and then go into desktop, and then go into my next folder, and so forth. This case I'm teaching, I'm realizing it's not as simple as I thought it would be. So this may be confusing half the class. But if you successfully do this, at the end, what would happen is you would call on your file. So anyway, the intention of this is like just managing file directories, that's all. And there's a whole line of code of this called command line and shell, which we weren't teaching this weekend. So let's say, keep this as a reference. I want you guys to explore that later. But for purposes of the assignment, we're going to use the pandas code that you previously learned to access your file. So keep this, and you can read into OS. And the primary reason why it's helpful is, let's imagine, here we go. So let's say I had another folder here called like old data. And imagine my Jupyter notebook right here is in the data folder, and I want to access the other folder. By default in Jupyter, you cannot access other folders unless you type the whole directory, or you have a working directory. So OS lets us switch out of the directories and move into new directories. That's what the intention of it is.
Now, when you go in and you're doing statistical analysis, then you have to specify which data set specifically you're picking it from?
Always have to choose your data set. So imagine if you're using data sets from different folders, you could be going out and into different directories.
I mean, because before when we were just using one data set, we wouldn't have to enter it each time because it was just pulling up the same thing.
Yes.
Now we have to specify every time.
Every time you have a new data set.
Well,
Or is it just
here's
the
what's
last
great.
one
So
that
if you have a
we're-
file, you would start by importing both data sets in from different
Together.
folders,
Okay.
and you can use OS to help you navigate to the folder to pull open the other data set.
Okay.
So if you're coming from multiple directories, this is a more efficient way of following that.
Because
as
you're able
opposed
to actually.
There's
in the
three
same
ways.
screen.
One way, you could just type the whole directory. The second way is you can, from your directory, go up and into the other one quick with OS. And the third one is to establish a parent folder working directory where all folders are under, but that's not always relevant because you might be accessing from different databases and stuff.
Right.
So OS it's a workaround to help you. I'd love to spend way more time on it, but I want to get into the stats. So it's just to show you that there's another way, and you can explore further. We're going to comment it out now because it would take a little bit for us to sync up everyone's computer with all the folders and everything. But note that that's something I'd love you to look into. Okay, so yeah, this is a little low, so let me bring it back up.
Yeah, you do.
Okay, so we have our data. Let's import it. Let's see if it works. Shift Enter, and you could even just then call, print data, or actually let's just do data.head, n is 5. See if we get some data. And if you're not getting this data, red sticky, so we can make sure you're in the right directory. Cool, okay. Okay, so we'll have a couple red stickies. Just note that we're not going to do OS for this, so comment that out. You can use your general directory. Oh no, oh yeah. So just as a reminder, you're using your computer. This is my computer. My computer is named David Jacobovich, so yours might be whatever your name is and your directory. So after, hopefully most of you are fine on this part. So one interesting thing we can do is I want to actually know the column titles, and I could do a loop for that. I mean, first I could just do data.columns. Well, not like that. Data.columns shows me the titles. But there's another way to do that. I could do for x in data.columns for the values, display out x, print x. So give me the value for each column looping through. And I missed something here. Python 2, right? And then we get the columns tiled out like that. You're going to start to learn that there's more than one way to do a lot of things in Python. Okay, there's other interesting things we can do. So I can create a temporary file, tmp, and set that equal to data.ix. So you've learned ilock. Now we're going into ix. Ix is another way to index. So what would this do? If I print tmp, I can't print tmp by itself. Oh, it says deprecated. This might be older. Hold on. Okay, so tmp doesn't work by itself anymore. You have to do .head. So I can print the beginning of the tmp data. And ix helps you set up the positioning. So this may fix it for you who had issues before.
It says, IX is deprecated?
Try doing tmp.head, and you open and closing parenthesis, and then closing another parenthesis.
Yeah.
It's deprecated.
It means it's like defunct and it's no longer active because it's an older version of Python. Oh, you have a space. So let me just, I'm going to mention this again. It's totally fine. Never, ever, 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 ever. There's no spaces ever between functions and things. It's a function and then the hard bracket. It's a function and then the parenthesis. You don't ever use spaces. I'm actually, I know that, for some of you actually type like this. They never even put spaces, some programmers, between equal signs, just so you don't make errors. So in Python, it doesn't use spaces. Here, you can put a space here for readability, but if you're afraid you're just going to mess up, just don't do spaces. That should fix it for those who are getting the deprecation error. Move into some stats functions. So we know we have some titles here, some columns: ozone, solar, wind, temp, all that. So I could say I want to take printing from the, see no space, print data, and I'm going to print from the ozone column the mean or the average. So here's a stats function, right? We now have the mean or average for that. I think Jacob already went through that, so you could really do data.ozone.describe, which will cover all of them, right? A lot of interesting things. Jacob did describe earlier. So that gives you mean, count, standard deviation, minimum, your IQRs. Similarly, if you really wanted to, you could do data.med, median, or not really, median. And now it gives you the median for every column. You could do .mode, you could do .max, you could do .min. So these are things Jacob showed earlier. I would say you'd want to print each one separate. I know I'm going super fast through the code right now, so I'm just being cognizant of that, but this should be a review from earlier. So when I move into the newer content, I'll drop the pace down a little bit. Right, so I print them all here, and if my syntax is not bad, I get them all showing down all these interesting things. But notice this isn't efficient, so typically that's why we like the describe method, because it shows all these things for a column. Okay, so this is not best practice, so I'm deleting that. But it's good that you guys like at least typed it to follow along. Okay, something else is interesting. Conditions. Conditions for what you want to find out. So let's say I want to print from the data frame. And then I'm going to do a hard bracket. So conditions, like a list, for a condition for when the ozone, data to ozone is greater than 31, and notice how these just turn purple, these are conditions, like logic, for when data dot the temperature is greater than 90, and being very mindful with syntax, and then referencing. So our naming, unfortunately, one of our columns I want to reference is called solar.r. So notice there's a dot there, right? Solar.r. So if I were to say I want to then, do all of this outputting for the solar.r, I'm going to break the code. So because we named the column very poorly, not you guys, but it was just named poorly, you can't do that here. You'd want to create a separate bracket and reference it through the bracket methods. Otherwise, we're going to break it. So if you're receiving code from someone that's named poorly, you have to either rename the column or adjust it as appropriate. And then after all of this, I could say, let's take just the mean. Let's take the average. I need to see if all my brackets look right, because there's a lot of brackets here, and I'm going to explain it to you guys more in depth. I think I'm missing one bracket at the end. Okay. If this works for you, you're going to get a number. And now I'm going to explain what we actually did. So don't put up red stickies yet. If it's not working, check your syntax. There's brackets everywhere, so if it's not working, chances are you're messing up on a bracket. But let me explain what we're doing. We are printing from the data frame, the data frame, something. And what we want to print actually is the solar.r. Solar radiation, right? If I scroll up, we know that solar radiation has big values. This is like daily solar radiation and whatever the units are for solar radiation. So I could have just said, let me just print the solar radiation, right? There's no issue with that. Let me just show you that this fails first. Print data.solar.r, right? So this is going to break, right? So it fails for the reason I told you, because it's not solar, it's solar.r. So that fails, but we could have just done print data solar.r, right? So that, I don't want to put it next to an error, so let me put it by itself. We could have printed it, right? And then all the data just outputs. But what I actually had us do over here, so I'm going to delete these guys since they're not really valuable. So I'm printing from data the solar R, but the average of it. But I don't want the average of the solar radiation. I want the average of the solar radiation when the ozone is greater than 30 and when the temperature is greater than 90. So this is a condition where all conditions, when both of these are false, the data is removed, and we're only taking the average when those conditions are true for solar radiation. So this is a way to do conditional if statements in a line of code if you're trying to get specific calculation. So this is probably new for many of you. For those who've done SPSS and other software, you're familiar with conditions. So I think, Grace, you've probably done conditions in SPSS. This is an example of how you can do that in Python. All the brackets, right? So the first bracket, the parenthesis, is just for printing statement. The hard bracket here is if we're going to run the formula. So we're running a hard bracket on data. And then the parentheses, whenever you do conditions, each condition needs to be in its own parenthesis group. So we have the condition, the data ozone column is greater than 31. I could put and or the pipe. Pipe is vertical lines, pipe means or. We're not going to really cover pipe today, but that is this guy. Maybe it's just one. 1, right? So this vertical thing, this means or. This is the vertical line above the enter on your keyboard.
The value is different from before.
Yes, because this means or. So this means either ozone's greater than 31 or temperature's greater than 90 and keep all that data, right? So now let me put them, just see, yeah, that's a great observation, right? So they're going to be different values, right? Because the one up here,
The new one?
this one is for either or is true. And this is for when both are true. Interesting. So that's some more of the logic, the Boolean that we were talking about, those conditions. I don't know if we're ever going to get the stats models, Jacob. I just went like deep into logic and other things, but yeah. I had a couple questions. Yeah.
Can we also interchange the column name first and then the Boolean?
Oh, what would one condition be? So this is greater and less. Let's say if I did print from the data frame where the month equal 6. And then I want to know the mean of the temperature. So what this tells us is I'm taking the data frame for the month when it equals 6. So for logic, you need to do double equal to match numbers if it's true or false. Because logic, double equal is for logic. Regular equal is like for variables or for calling strings and syntax. And then the temperature, the mean. So you can probably see now that even though we're covering the tip of the iceberg here, introducing these greater, less thans, and equals and not equals, you know, we could have done not equal here, right? So not equal to is exclamation mark equal. So we're seeing we have all these different types of logic. You can now do more powerful stats, which typically in Excel you would filter, right? Like you'd remove conditions. So this is like conditional formatting in a sense. And you can apply any function here. So I could do this and then say, you know what, just describe it to me. So for when the month is not 6, which is January, February, March, April, May, June, when it's any month that's not June, describe the data versus just describe the temperature. So if we did something like this, you can see how with June, with June the temperature is higher, right? And otherwise it's lower. So maybe June's like the hottest month on record. So you can like exclude June, see if it's biasing the data in this case, and then keep June with everything and see the difference. What are the percentages? What's the max and min? You know. Cool. All right. I had 8 lessons I want to cover on statistics. We just went through the first.